All right, I have the auspicious distinction of standing between you and the great outdoors and your relaxation and buffet. So we'll try to make this as interesting and lively as possible. So my name's Jan Newton. I'm at the University of Washington, and I'm the executive director for IOOS. It's one of the IOOS regional associations. Also, you see up here on the board IOOS for Central and Northern California Ocean Observing Systems, and IOOS, Southern California. And we have representatives from IOOS and IOOS. From IOOS we have, who's here from IOOS? Yes, Skyly. Thank you. Leib was going to be here, but I guess he didn't make it. And then from IOOS we have Lisa and Darren, right, up in the cheap seats. Great. So anyways, Emilio and I are going to tag team about as Andrew introduced this session, so once you get the data, what are you going to do about it? And Dan Rudnick from IOOS as well. Sorry about that, Dan. What are you going to do? And I think that the IOOS regional associations have great capacity to help. I think we're not there, obviously, all the way, but that's what we want to explore with you. So, so Dick showed this slide of the IOOS layers being an end-to-end system in the sense that it connects with the stuff in the water. There's that data management and communication layer. There's modeling and analysis. There's products and services that go out to people that need to make decisions based on this. And that could be a scientist, that could be an industry person, that could be a manager, that could be a government, whatever. What I want to do is actually take you to the origin of IOOS, which is, well, it was called for Congress in 1999, but the System Act came 10 years later. But what is really critical for people to understand about IOOS is it in the Act, oops, I tested this, am I doing it wrong? Oh, there we go. Boy, don't you hate this when people do that? There we go. Integrated system, federal and non-federal partnership, and it has all of those data layers that I just showed you, okay? So a big key with this, I think your battery's giving out, we'll switch back to red, is this federal, non-federal partnership. All right, here are the federal partners. It's just about everybody you can think of, NOAA being the lead agency. There is a U.S. IOOS program office in Washington, D.C. Well, it's actually in Silver Spring, but that is housed within NOAA. But you can see there are a lot of partners who contribute less or more. The regional associations were created to be this middle ground who can engage with diverse local stakeholders and assure consistent national capability. Now, consistent is a word that is certainly something that has many flavors of, but in terms of being able to assess, for instance, let's say some critical resources in the nation. So they've established different areas of focus, which include ecosystems, fisheries, climate, coastal hazards, and there's one more. Anyways, so trying to get more of the data into our national system, but that is very much rooted in the region from which these regional associations, there are 11 around the nation, hail. All right. So I wanted to show you another quote from the System Act, because I think it's really important, is that, you know, a lot of times people hear about these ocean observing systems, they say, oh, isn't that wonderful, and okay, you guys are serving data, and this is just this standalone system, and you know, this is good, and there's lots of different ocean observing systems. But the IOOS system was really, in law, said to be necessarily a federal, non-federal partnership with the mandate for data management, communication, and modeling systems for the timely integration and dissemination of data and information products from the observing system. So we are mandated to serve data and to be integrating that data. And you notice in the slide previously I had over to the side leverage and link, and I think that's really critical about what is unique about having a regional association. It is not a federal entity, and it's not an academic entity, and it's not a government, regional government entity, and it's not an industry, and it's not a nonprofit, but it's all of those. It's integrating all of those, okay? So that is actually our federal mandate, is to do this. All right, so each of the regional associations has taken a good look at what's in their region in terms of the natural complexity. They've taken a good look at their regional user groups and some of the nuances that make it specific to their region. And then each of the regions has come up with their conceptual diagram for how they want to spend their observing resources to get at the priorities that they've established, as well as the needs of the user groups. So in IOOS, and I can't speak for CENCUS and SCUS, but I can say that the first thing we did is take a look at what was existing and start integrating that. Now, some people think that's a flawed recipe for making something, because they'll say you'll inherit all the bad things about a system and you don't actually have a system. But from my perspective, many of the systems, at least along our coast, have been put in for very good scientific reasons. You know, they're located in good places. So for instance, when NH10 was located where it is in Oregon, they did it because it was a good location to study some of these coastal processes here. So there's no need to say, okay, we need to start from a blank slate and start over again. Now, is it sufficient for everything that we need to be doing in terms of these interrelated coastal ocean observations? No. But is it a good starting place? I think so. So each of the regional associations has worked on their data delivery system, because that is really, as you saw, part of our federal mandate is to serve the data. It's not just to have toys in the water. It's not just enough to come up with having good systems for observing. It's to get the data out to the public, out to the hands of various user groups. So here's a look at the IOOS system you saw earlier. Here's a look at the CENCUS system, and here's a look at the SCUS system. And these data delivery systems are very complex, and each RA has developed similar capacities and different emphases on what they're doing. Once again, largely based on who's involved, perceived needs of the region, and where, in a lot of cases, where there's good traction to have success. All right. So the payoff for this concept is, and this is just an example from the IOOS region, because obviously that's the data I have close at hand. From our IOOS, US IOOS award, we have funds that fund 19 data streams from these folks, academic and state agencies, 19 assets. But on this display, we display data streams from 167. Groups, okay? So that is really where the benefit, the investment of the whole IOOS concept is making the traction, is that build a system, they will come kind of concept, in the sense that this NVS display in our region has been judged to be a very worthwhile data stream portal. And so folks who aren't getting any funds are saying, hey, we'd love to have our data as part of the IOOS system. That includes Canadians up here in Venus. That includes some of you in the audience, and I'll talk about the liaison we've had with the shellfish industry and a lot of other groups. And so that's really where there's payoff to the system, and it fits with Congress's overall idea to have this integration of federal, non-federal assets with the data getting out to the public and user groups. Okay, Dick showed this slide earlier where we have ocean acidification relevant data from a buoy that UW got foundation funds to deploy, and NOAA is putting their PCO2 and pH sensors on it. The Taylor shellfish data for the pH from the Pacific Coast Shellfish Growers Association, and then the Seattle Aquarium. We've been talking about that as a concept for an entity who has the desire to make measurements and has gotten like a pH sensor. My point in showing this again is that while the regional associations have been doing great with getting these data streams, you know nothing about the specifics of the data, how well it's been calibrated. That's not to say that these metadata don't exist. You can get them. But in terms of an OA network, it's not obvious to you at the outset. So one of the things that I think is critical, and I know you can't read this, but it's up for me to read, is an outcome from another workshop that was recently hosted in Seattle on national data integration for ocean acidification. And we made this thing called the Declaration of Interdependence of Ocean Acidification Data, recognizing that if you're going to study processes in your little cube of water and you've got your sensors to adequately do that, you can stand alone. But if you're going to study ocean acidification, you really need a wide variety of data, and we need to be able to look at data that's coming from National Science Foundation studies or NOAA studies, et cetera, and that we can't be stovepiping this. Emilio will talk about progress on this, which was that we need program directors and managers to be advocating for this and telling their data managers to work towards this. We need to contribute to a portal for our nation. But the reason I put this up is it says the commitment of the scientific community to establish best practices for OA data collection and metadata production. Okay, that's something which I feel is fundamentally lacking. And so whatever data the regional associations are going to serve, it's not going to be of the quality that CCAN needs unless we do those best practices and protocols for metadata. So that's my soapbox. All right, so the regional associations have worked with shellfish growers and others to make decision-making tools. This is an example collaboration with the National Estuarine Research Reserve. This is a example from Senkus where they're looking now at some indices. Let's see if I can see them. Temperature, chlorophyll, salinity, pH, precipitation, and then somewhere on here they have the upwelling indexes as well, and trying to get some initial progress on looking at conditions that are happening when different observations on perhaps shellfish recruitment or settlement are happening. So these are the kinds of products that regional associations work towards making, having those data streams but presenting them in a way that may facilitate a decision. Also, here's an example from SCOOS with amazing time series, this one going back to 1925. So that was just to show you that different regional associations have come up with different products that may or may not be useful to the needs of CCAN. Also, these data delivery systems have been implemented on smartphones, iPhones and Android systems, because we recognize a lot of folks are in the field and not in their offices in front of computers. So that's kind of just a brief introduction to the IOOS system and the concept of regional associations. I want to take a couple minutes more to talk about some California current scale collaborations that are going on, because obviously these three regional associations, though we're trying to do serve our needs within our region, we're all part of the California current system and we want to interact together. So step one was that the three RAs, NANUS, Senkus, and SCOOS, developed a memorandum of understanding between the three of us. And this recognized that there were certain issues, OA being one of them, harmful algal blooms, surface currents, et cetera, being others, where having that coast-wide view was really valuable. So we set about, I guess it's been a year ago or more, to establish a memorandum of understanding between the three regional associations to work on coast-wide things. These three RAs actually submitted a proposal to NOAA MIRHAB program to work on a West Coast-wide data portal for harmful algal blooms. Unfortunately, MIRHAB lost their funding, though our proposal was rated very highly. So it's a serious commitment to work together. The next step is that the 3 regional ocean observing systems are in the process of getting a memorandum of understanding signed, we hope, with the West Coast Governors Alliance for Ocean Health on the West Coast. So this is going to be an important step forward of taking now these regional IOOS associations and getting them married more effectively with the West Coast Governors Alliance. And I'm pleased to say that the California Ocean Protection Council meeting that Skylie mentioned earlier is also going to be talking about whether they recommend that the West Coast Governor Alliance for California representatives sign this MOU, and Andrew, on behalf of CCAN, wrote a letter of support for that concept, so we're really appreciative of that. I think this will be an important step in going forward. So many times you know what is important to do, but nobody has the gumption or the feeling that this is the thing that should really push it forward. And sometimes these pieces of paper have an amazing amount of clout to get us off of the dime. So we're hoping for that. And so I want to conclude with thinking back in terms of CCAN and its development. At our first CCAN workshop, as we were talking about the regional associations and that, wow, you know, we do have some capacity for observations coast-wide, the desire was to have an inventory of where those observing assets were. And the concept, whoops, hang on, I'll get there. The concept was to take an inventory from the regional associations of 2 different groups. Group 1 is measuring carbon parameters such as pH, PCO2, DIC, and total alkalinity. In our CCAN 1, we came up with a recommendation that 2 of those be measured with water samples for calibrations. This did not distinguish, it just is looking for assets that are measuring those carbon parameters. Group 2 was temperature, salinity, and oxygen, because those are ones that would be amenable to using the algorithm that the NOAA PMEL group has been working on. And I think somebody brought up the good point is whether those algorithms are applicable in estuaries. Likely not, they would need to be tested, but for sure a good portion of the California current likely would be so. So Emilio Mayorga, who's going to talk next about the details of our data systems, worked with the 3 regional associations to create this inventory. Diane sent out the link. This is a website that you can get to. And so there's color coding here. Group 1 is red, group 2 is yellow, and so when I blow this up it gets fuzzy, but you can see where we have measurements. And of course the Cal Coffee system off of California here is extensive and amazing and does have carbon parameters. Up in Washington and Oregon, we don't have a similar type of continuous or regular repeated surveys, though NOAA PMEL does the coast-wide surveys. But you can see the smattering of dots right now. You don't know what those dots are. But anyways, the other way that Emilio structured this was by type of observing platform. So the types are yellow dots are gliders, red triangles are platform sites, blue stars are survey area midpoint, and blue dots are survey stations. So you can get a lot of information from this. So I think we have some good starting points in our region towards this CCAN network. I think it is critical that we get the best practices and the trainings available, but we'll talk about that, I'm sure, tomorrow. Here we're to talk about the data and to get down in the details of the data. But I wanted to report that this inventory has been made, and you're going to hear more about the capacity for data from Emilio. Before I turn the baton over to Emilio, if there's a couple, like 2, 3 questions, we can entertain them now. Otherwise, I'll ask Emilio. Any questions? Dick, and then Andy.
The question I have is, these groups that provide data to you and then you transmit them to the NANOOS systems, is it their responsibility or your responsibility to then pass it on to the National Ocean Data Center? How does that work out?
Emilio can give you the details, but it's automated basically, because once something gets into the NANOOS system, it automatically is on record with the US IOOS system. You can even see it from the US IOOS website. As soon as it's on our system, it's on that system. And then in terms of NODC.
You asked about NODC, right?
How do they fit in?
Yeah, there are plans for how it ought to fit in the future, and that's not quite implemented yet. What's that? Okay. What is definitely in place is our commitment to IOOS to forward the data to IOOS, and sorry, I have a good voice, and to the IOOS network. So definitely anything that gets into our application, the application that Jan was mentioning, does get to IOOS, but not necessarily NODC. I think we as a larger community are still sorting out through multiple threads of data that are a burden. And NODC is not quite, there is no smooth path yet directly to NODC, but the endpoint has been defined, and I'm hopeful that within a year or so, we won't have to duplicate all these paths.
I want to point out that this is not an easy issue. The reason it's not an easy issue because associated with each data stream has to be a very detailed metadata stream.
Yep.
And which includes all the calibration information and other information as well. And it's the responsibility right now of the individual scientist to make sure that those metadata streams go along with the data streams so that NODC receives their entire package. If we're going to put together a program like this where we create a stream of data sets that will then be integrated and to submit that through the National IOOS office to NODC, we have to ensure that the metadata sets are replicated properly. And so this is something we have to spend a significant amount of time thinking about how to do that.
So Emilio, do you have anything in your presentation about metadata and what? Maybe you could address that as part of your talk, because I think I think Dick's point is excellent, but I think we are not starting from scratch. But let's hear your thoughts on that. Stuart, you had a question.
So one of the things I was wondering about was some of the data and products, the visual products that you were showing. I was just wondering, how do you get to those end products? How do you get to those data end products that you're showing online? Is that all coming from stakeholder feedback? And can you just talk about that process?
Sure. Well, from NANOOS's standpoint, when we did the project with the NERS, basically Kathy Angel, that was from the National Estuarine Research Reserve, had a concept of getting real-time water quality in the hands of shellfish growers. She established a relationship with us at NANOOS, and then we together established user groups, or what are they called? Focus groups that put out their desires and their information on what kind of an application they wanted. For instance, they wanted Fahrenheit as well as Celsius for the temperature, so that was a specification. And so, yes, close stakeholder involvement is really critical. Now, I won't say every single application you see on all three of our RAs has followed that pattern. I don't know, but I can say that in NANOOS, it's very common practice to have those focus groups. For instance, we're doing one for maritime transportation, where we look to the Marine Exchange and the Columbia River pilots and one other entity to get their advice. Start out with a few people, get their input, and then start expanding the circle. I was just going to switch the lead. Okay, if there's, yes.
It's a question I should probably ask Copy Break, but Conceptually, continuous measurements with flow-through stuff on ships, and then there's station work, which gives you like a full water column profile. And they're obviously valuable for different things. But the fisheries half of NOAA is going more toward acoustic surveys and staying on the water almost continuously. So there's just a huge amount of ship time. I guess my question is, are the surface measurements, through-hull measurements, the most valuable thing, or is it the station work that shows you all the way down to OMZ? And I know there's not an answer for that.
Yeah. I think they tell us very different things, and I think both have useful applications. So that's really a waffly answer. It's an easy way out, but let's talk at
But do you
break.
serve some of the continuous data?
Do we have any continuous data?
I'm sorry, I was working with my computer. By continuous data, you mean
Like
If
flow
you're just
through?
running a through-hull sort of pH type thing,
Like the
or is it,
clipper
is
would be
most of
the
these data
example.
sets
Yeah.
just sort of station?
the vast majority of the data that we serve are specific stations or platforms, moorings, buoys, gliders, and that's not a stamp of approval of saying that that's what we consider to be the most important. It's partly a combination of IOOS priorities, sorry. Yeah, I couldn't see, of IOOS priorities in the past that tended to lean in that direction, and we had to be responsive to that. And that data is often actually easier to handle than, for a number of reasons, than ship or data. So again, it's not a statement on our part or the part of regional associations that that's more valuable data. It's just the reality of a number of factors that have resulted in that.
Yeah, and likewise the metadata that would go with continuous underway. So you basically haven't tackled that half of the data stream yet.
Not as consistently as we have the near real-time data.
But we do have one.
Yeah, we do. Every regional association, for example, you saw CalCOFI in there, and I know the California regional associations probably do a great job of working with CalCOFI to have the data. In NANUS, we have at least two programs. One is called both in Puget Sound. It's just that they're not as well integrated with what we'll show as the near real-time data.
Can I interrupt for just a second? I've got a couple of chat folks that would really appreciate it if you guys speak into the microphone because they can't hear. So please.
Thanks, Diane. Okay, I think we should turn the floor over to Emilio for a little bit more in-depth analysis of the data management systems from the regional associations, and as soon as it's up. But just to, yes, we do have an example of a ferry, the Victoria Clipper, that goes between Victoria and Seattle, and the state agency, Department of Ecology, has made a liaison and put some sensors on there, and we are serving it through the NANUS portal. But as Emilio said, if you look at the majority of in our region, I would offer that there aren't that many of these flow-through systems in our area. But anyway, so it looks like Emilio's ready to go, so I'll turn it over to him.
And this is the first time I come to a CCAN meeting. I have been involved, like Jan mentioned, on that asset inventory. So I'm not here to propose solutions, but rather to talk about our experience, following sort of the template that Jan followed on both the focus on regional associations, but also on these different scales of geography and networking of groups. That would be the national scale and the West Coast scale. So that's the sequence I'll follow and try to talk about what activities are happening that I think are relevant to the goals of CCAN. Jan has already covered what IOOS sees and what its mandates are. Just highlighted the data part of IOOS, which is at the core of IOOS's mission, which is to integrate data from a wide range of partners, both federal and non-federal. One application that I use, a pilot application that I use deployed about 2 years ago. It was more of a proof of concept. It was called the IOOS Data Catalog. This application shows all these data streams brought together at the national scale in one place. Again, I would consider it more of a pilot application, but at least it shows the potential of integrating data streams from different federal agencies, as well as all the groups that, local groups that the regional associations aggregate and bring together. I have a lot of text here. I participated in the two OA workshops that have been mentioned, the National Data Management one in March and the international one in June, both in Seattle. So I'm just recycling some of those slides, and they might be useful later in discussions. Just wanted to highlight a couple of points, that there are many challenges involved in data issues. Dick pointed out or highlighted the metadata issue, which we are certainly not addressing well in IOOS, at least. NODC has its own challenges in integrating this data and metadata. So we have diverse observant systems and data streams to potentially integrate. A diversity of frequency of collections that includes both discrete sampling with substantial delays or lags and near real-time data streams. Different regimes for the environments, open oceans to coastal. Different kinds of approaches to QA/QC and goals, and ways of documenting what QA/QC approaches are being followed. And also different types of potential products and uses for that data that are, in many cases, are yet to be specified. So this is not a simple problem in any way. So a generic list of some of the ingredients that it must be considered, again, not a solution, but just the elements that will be a part of any solution, are to consider the data lifecycle from start to end, and what is currently being done for any given data stream, and what are the gaps, and how do we meet them? What are the different components of the network, and whose roles, who has a role in those different components? Are we targeting, we've used the dichotomy, I guess, of the climate versus weather applications and the implications for QA/QC. So are we targeting, in cases where we're targeting high quality data versus more weather-oriented sensors or data, what implications does that have for handling data? Also, there are, as we look at the community of relevant data systems, there are some systems that have been around for 10 or 20 years or more and are so targeted that they can do an extremely detailed and integrated job. And maybe the atmospheric CO2 monitoring program is a great example in that they're measuring a very common parameter and have been doing this for a while and have been working together for a long time. IOOS, I would say, is a more broader and looser connection. We do have funding mechanisms through the regional associations, but Jan, when she made the distinction between assets that are funded by NANUS versus those that are not, one thing that she forgot to mention, I'm sure she normally would, is that those that are funded by NANUS, and I'm sure it's the same for every regional association, I don't think there's a single one that gets more than 50% of the funding of any individual buoy. So it's a challenging environment, I guess, to leverage different funding streams and create a consistent whole at a national scale. And as a result, IOOS is a sort of loose network that brings groups together from different entities. In general, pragmatism must be the name of the game. We have to learn from and build on existing data systems, be it IOOS, be it NODC as a source of archiving, permanent archiving, build on protocols that exist. OA doesn't occur, OA monitoring and OA science doesn't occur in isolation. Certainly pH, CO2, it relates to the carbon monitoring programs that have been going on for a while. Temperature and salinity are part of the monitoring that has existed for a very long time. So we have to take advantage of that. And that's just a long listing of a number of programs that are relevant as we move forward. One of them, Ocean Sites, is, I think IOOS was here. So it's definitely one highly relevant program. I'm going to borrow some more from these workshops that had taken place, and from the U.S. data management, OA data management workshop. There was follow-ups from data management leads for a number of groups, including CDEC, the BCODEMO from the NSF Chemical Oceanography Data Support Program, NODC for sure, IOOS, and some others. So there were some discussions that helped advance the main items that were identified at the workshop, and more progress was made in some directions than in others. But in general, the challenge is that there are many organizations that could contribute diverse types of data with all sorts of issues of data quality and lineage. And a common theme is that there are small amounts of funds for data integration. This was equally applicable at the global workshop, an international workshop, and I'm sure it's just as applicable at this workshop. And as Jan emphasized, this will require a close collaboration between science and data groups. Some of the highlights or thrust of the National Data Management Program include providing unified access to OA data for humans and machines, ensuring that data are version control and citable through globally unique identifiers, and so on and so on. I don't want to read every word. These are statements of goals of where we want to head. They're definitely not statements of where we are, or not even where we will be in a few months. But again, these are common things that are, in all these workshops that we've had, have been identified as common concerns and needs by everyone. As an outcome of this National Data Management Workshop, this cartoon or paradigm emerged that also is applicable, I think, to any group in how we would structure or envision a community of a collaborative community where the observation community, there may be separate segments of observation communities, maybe ones that are focused geographically on different parts of California or the Pacific Northwest. Others may be more thematically focused. Those groups may coalesce and work together and have their individual data management staff and collaborate more closely. So when you have these different groups, ultimately the data management staff that work with each individual group should also talk among themselves and create a community that can lead to that, whether it's a centralized system or simply a mechanism for defining data standards and conventions so that we can work towards the same goals and the same standards. But ultimately, each group is still responsible for a part of the system. One model, of course, is to set up some sort of highly centralized system that has a lot of authority. Generally, that's highly unlikely, I think, in this sort of collaborations. When you expand that model, then one possibility and one way of viewing this is that each community could be by platform type or by observation system. The mooring community organizes itself. The repeated hydrography organizes itself. The community that is producing synthetic products organizes itself and has its own needs and data management staff. But we work together at the level of integrating data and metadata to move towards the consistency. Consistency both in terms of how data is served, how metadata are served, and how QA, QC procedures are documented. Not that in every single instance, the level of quality control is identical, but rather that it's well described. I think I'll skip this. It's one example of concrete steps that this work is leading to, or concrete needs that we can make, that we're starting to make progress on, are things as simple as using common vocabularies for the same, common names for the same variables, be it CO2, pH, etc. This is just an example from a paper from the EPOCA program where they calculated other carbonate system variables based on two variables that were available and decided to add a systematic flag for which variables they used and what software or algorithms they used to calculate the other variables. So they published this highly detailed way of flagging how they derive data. Not suggesting that that's what we would do, but those are the sort of issues that arise in terms of what variables are used and what flagging system would be used either for QA/QC or for how data are derived. One pilot collaboration that we have started as an outcome of this meetings and collaborations is between NODC, IOOS, NANUS, and Sakura, which is a regional association in the Southeast, and possibly OOI. And it's a simple goal, really. It's just to agree on a common vocabulary for variables, as for PCO2, pH, et cetera, so that these separate data systems can identify things that are roughly the same as being the same in order to facilitate the discovery of data sets that have these variables. This is actually not something that is entirely, that has been solved. I mean, it has been solved in an intellectual sense, in that there are intellectual solutions, but things, and institutions as substantial and important as NODC don't have a controlled vocabulary that is widely disseminated. They have their own system with their own issues. So we're starting to talk, we've had several conference calls to figure out a pilot project to initiate some concrete collaborations that will lead to concrete results. Another outcome that NODC has led is the creation of a metadata template for OA data. There were definitely the leads on that. The rest of the community were queried and gave input, but that's a concrete outcome also that you can find from the NODC ocean acidification page. So I wanted to focus now on regional association. And again, I'll use NANUS because that's what I'm most familiar with, but something similar would apply to other regional associations. We've seen this plot before also. You can see all the different assets that we present and some of the data that is included. Jan has already addressed, I guess, what motivates us to develop this sort of applications, that we are, as a regional associations, are facing two different directions. One is to our users. The reason for being for regional associations is to be able to work closely with local providers and local stakeholders. But at the same time, we're part of a national network. So we had to be very responsive to those sometimes conflicting needs of people who want data for a specific area or region versus the national network that is more interested in integrating data in highly consistent ways without necessarily being in touch with these local providers. So we, like other regional associations, strive to bring to the table a strong focus on usability and good user experience and consistency while being responsive to the IOOS mandate to create a national system. I can't remember if Dick showed this plot also, but one of the things we're able to do in order to support users is integrate data both from observations and forecast. And this is an example where for one buoy, an H10 from OSU in Oregon, water temperature is being measured, and there is a forecast from a NOAA group. I believe this is, no, this is actually from CMOPS on the Columbia Estuary. When we have a forecast model that measures, that provides the same variable, we're able to provide automatically comparison plots of observations versus models, which have value to users because they're able to make their own assessments about how accurate or reliable that model may be. And we can do that for any model, really. In this case, this is a model from a core NANUS partner, but you can see those three, oops, sorry. Okay. There are two other tabs in there that are models from, in both cases, from NOAA, so they're national or larger scale models. This is an example of not flow-through system, but definitely a ship cruise system, survey, unlike the individual moorings that we provide for the Pacific Northwest, integrated into that same application. It's called PRISM. It's a set of cruises that have been going on for about 14 years or so. So in this case, you're seeing a plot of this from a CTD, I think, a depth profile of, well, oxygen, but it doesn't matter. And this is, we consider this an important data set for Puget Sound. And because we at the UW control this data, we were able to move forward with it. But because of the challenges with this kind of data, we haven't been able to do the same thing for all available data sets of this sort. Again, also for that particular cruise program, we're able to create these cross-sections. But unfortunately, we haven't been able to push it farther to create a general framework. This particular application allows you to select assets based on what we call filters. They could be variables like chlorophyll, dissolved oxygen, or it could be geographical filters like Washington State or platform types. What I'm showing you here is just a selection based on variables measured, in this case pH or PCO2. This is selecting all the assets that are measuring pH or PCO2. So in terms of usability, it allows you to zoom in pretty quickly to group 1, I guess, ocean acidification assets. Now, this is the Pacific Northwest only, but you can imagine something similar for the West Coast or the California Current that would allow people to select subsets. Jan also mentioned that, or talked about the partnership that we've had with the shellfish growing community in the Pacific Northwest. So I wanted to talk a little bit about that because we think it's been a great example of the strengths of regional associations and in developing mutually beneficial relationships with local and national communities. This relationship includes the Pacific, what is this scene? A coastal shelf. I'm sorry. Shellfish Growers Association, yeah. Pacific Shellfish Institute, the Taylor Shellfish Industry, Whiskey Creek Hatchery, so we have Benoit, Andy, and Alan here. And potentially, although we're still waiting, at the Vancouver Island University in British Columbia, we have been working with them to make their data streams, their near real-time data streams from their hatchery or beds or shellfish beds to integrate them into NVS in order to both become part of this regional network and provide that service to a larger community, but also to serve themselves. In some cases, they may not have had easy access to that data. So in working with us, we're able to provide a service to them, hopefully. And we're also able to hook it up to the national network, to IOOS. What we have set up allows, as soon as one of these data streams flows into our system, it's automatically available to the national data network. Because this has been built up gradually, but I think it's been a terrifically successful example of a community that can support each other and where we can work together without exchanging a cent. This is a case of a community that gets no funding whatsoever from NANUS, but they've adopted similar schemes for data transmissions that have allowed us to start documenting this so that the next person in the group can benefit. And this has happened several times already in the group. So because it's happened enough for the last time, the last deployment, which is Alan's Whiskey Creek one, we took the extra step of starting to document this so that it could be a bit more formalized and more useful to others. One of the things we do with NVS also, and that we consider a service both to the data providers and to our users, is to provide brief logs of activity on individual assets. So in this case, June 22nd, the monitoring side came back online. This happens to be the Bay Center port mooring in Willapa Bay that Andy manages. And I've been told that that the mobile, the smartphone applications, like Jan said, are also very useful because they allow people to check the status of their platforms from anywhere, really, and be able to react more quickly. Another way where filtering becomes very useful, another example of filtering, in this case by keyword, I entered the acronym PCSGA, and here are all the assets that are linked to this network, I suppose, in the Pacific Northwest.
again, you can envision this filtering mechanism as something useful for discovery and grouping on a West Coast scale. And this is only possible, especially like something like pH or PCO2, if the metadata, the labeling of variables, is systematic all across. Another advantage that we try to, or another benefit that we try to bring to the table for providers who are willing to work with us is adding other capabilities on top of our data flows. So this is an example of an application that we unveiled 2 months ago or so. The long name, CMOP Data Explorer with Nanos data. This is deployed at an Oregon institution that is, has access to the data stream from NVS and can mix the data streams and the variables in ways that NVS can't do just yet. So what I'm showing here is three pH from 3 of these sites from this collaboration for the last 15 days. So you can see I did this this morning, I think. So you can see that this goes through, what is that, midnight yesterday, I guess. Well, it's a bit odd. But anyways, the last 15 days. Not necessarily a scientifically meaningful plot, but basically by working with us and allowing us to integrate your data, our hope is that we provide a service to the data provider, but also a service to other stakeholders who may be interested in this data. And other things can flow from this integration that would have been very difficult if we didn't collaborate. This is, yes?
Go back that last slide. This is a very good example of what I'm getting at.
Yep.
How do you know what pH scale you're working with these 3 different groups?
I haven't mentioned this, but definitely one thing we have not done in NVS, and it's probably, I think most regional associations that are at that stage have methods are used to, or sensor types are not presented here. So the pH scale, for example, is not something we're presenting at this point.
Okay, well, this is a clear example of
Yep.
why we have to worry about the metadata, and the proper interpretation of data can't be done unless that's there. So
Absolutely.
we have to spend more time thinking about how we're going to do that and presenting it in a way that's reasonable. The differences between scales would be observable in these charts.
I think that's a fundamental challenge that we face, definitely among regional associations, but in the wider community. If you take 2 end members, I think, of 2 extreme strawmen, one would be throwing any data whatsoever, integrating it this way, regardless of what metadata exists. But the other extreme is waiting until all the metadata that one would consider to be necessary for it to be available before we provide it or disseminate it more widely in some way. We try to be midway somewhere and try to create a positive feedback that way. But it's definitely not in any level that makes us completely happy, I guess. Jen?
Yeah, I would say that IOOS is starting this process. The acronym they chose is QUARTOD, which is Quality Assurance of Real-Time Ocean Data. But they're going to go through variable by variable. They started with what, temperature or salinity?
Yeah.
Anyways, one of those. And I think this is where CCAN and maybe products from this group could really lead the way in defining what are the critical issues for the metadata, what are the critical things that we need to be doing exactly to get at the heart of what you're saying. But right now, those things aren't written, and they're not going to get written unless somebody steps forward to do it.
Just be aware also that even when they are written, it requires resources. And that adding that richness of information requires more effort. So that's part of the reality. This is just an example of what I was mentioning earlier, that when a data stream gets incorporated into our system, it becomes available to the IOOS national system. So this is the data catalog that I showed earlier from IOOS, showing Whiskey Creek. I'm sure you can't read it from there, but basically the day after we integrated it into NVS. With proper acknowledgments that this was coming from the Whiskey Creek entity as opposed to NANOOS overriding the original acknowledgments. addressed most of this already. I wanted to step out to the West Coast scale and just mention a few efforts that are in place. Jan already mentioned this MERHAB, or the proposal that we wrote to try to collaborate among the 3 RAs on a West Coast scale on harmful algal blooms. I think this is a case where we are trying to take advantage of the strengths of each RA, and SCOOS in this case has done a terrific job of advancing the capabilities for harmful algal bloom monitoring and ingestion of data, much better than IOOS had. So we built a proposal that took advantage of each of those strengths to create a bigger whole for the whole region. I think that's what we would envision for ocean acidification as well, where we in IOOS may have certain strengths that derive from the fact that the shellfish industry is just very important in the Pacific Northwest. But we strive to seek that complementary relationship and to exploit the advantages of each regional associations to leverage our work. This is another example where SCOOS has been a leader in high-frequency radar national network. May not relate to OA directly, but I think the principle is the same, that one regional association stood out and became a national leader, and then we all benefit. We all leverage from that. There are lessons that could be learned from those successful examples that may apply to OA. This OA asset inventory that Jan mentioned already is another example. We worked together and defined what parameters were feasible, were desirable and feasible. And this is only an initial preliminary inventory. It definitely has a number of gaps. We've identified some of those, but we consider it only a first step, first solid step. So this is what you will find in the Excel file that will be downloadable, hopefully within a couple of days. And Jan already showed this. Another example of a West Coast collaboration, Jan mentioned the West Coast Governors Alliance. One area, even though the MOA isn't written yet, we have been working together within the 3 RAs and supporting the West Coast Governors Alliance in this effort called the Regional Data Framework. This is more oriented towards what I would call GIS data rather than specific chemical measurements. But again, I think there's overlap between what a project like this has as a goal, which is to create coordination in data and identification of gaps across the West Coast, and in order to minimize duplication. At a higher level, it's the same principle as what we're trying to do here. And some of the tools that will be developed by this project may be applicable or may be reusable by CCAN as well. This has been funded. It's starting to move forward. This is what it may look like based on the group that is developing the data catalog and portal, who's also responsible for this portal in the Mid-Atlantic. We'll leave it at that. Just lots of text that we can use for discussions.
Thanks, Emilio. Thank you so much. So we have some time for discussion now. So let's get some questions either down in the weeds or up at the cloud level in terms of what you see, what you like, what you don't see. So Bruce, I will give you the microphone. There's also microphones on.
I just wanted to talk about that. Oh, are you, I mean, did I understand it that you're requesting that people describe their QA, QC, like what instruments they're using? And I mean, do you make that request? Because when I go through the sites, it just seems kind of discretionary whether people want to say that or not. Like they have the King County sites up in Seattle. And it'll tell you, we use a YSI with an accuracy of not very good, 0.2. And then other people say, well, we use a Durafet. I know the site at Santa Cruz down at Sencus, it describes that they're using a Durafet and what the accuracy of that is. But I guess the whole point of my question is we kind of struggled with this earlier of do you just flag what instrument they're using, you know, if it's less accurate than what we want, or do we put this into tiers? I mean, That's something that we struggled with. Do we do the grading and then assign you either you got decent, accurate data or you got kind of questionable data? Or do we just leave it up to the end user to go through all those QA, QC questions and make their own decisions on that data set? Because when you were comparing that one data set that you were comparing what was happening, I mean, how does somebody know? Like Dick's question, how does somebody know that that data set's comparable when you're using different instruments?
So correct me if I'm wrong, but I think you're asking two different questions. One is whether we, and I can't speak for the other regional associations, but whether we in IOOS are doing that. And the other one, I think, is whether it's what we in CCAN should do.
Because okay, basically.
Definitely in IOOS, in this particular application, we're not doing that right now. Sounds like you've been there and have seen it. So we're definitely not capturing and forwarding or presenting information about the sensors, or much less the uncertainty, or the QA/QC procedures for the sensors. In some case, it ultimately boils down to the amount of effort that would entail to integrate data, to integrate that level of information from the different sources. And effort equals resources and money, and we haven't been in that position. Again, is that something that we would want to do? Of course. And if CCAN, it sounds like that'd be something fundamental to CCAN, but it doesn't come without cost, basically.
Just so we put everything into perspective, when we deal with open ocean climate quality data, we have very rigorous steps to go through the process of creating quality flags for every single data point that exists. And that was set up by the program. So the question is a relevant question whether or not CCAN wants to go through that type of rigor or not. But we do so in such a way that when data are presented in a format like this, then you have the ability to choose which quality data you want to present. And therein lies the strength of that capability. So if you want to have extremely high quality data presented in which the metadata is there and you can know what scales that are on, you only present those high quality data. If you choose to present all the data, then you may have a problem figuring out what the quality is.
Yep.
So these are the very valid questions we should be asking of CCAN.
Other questions? And I'll just, since I don't see any hands up, one of the things that I think is really, that this RA structure is conducive for is creating a new portal, a CCAN portal, that is fed by these data streams, but filtered in the way that CCAN wants it to be. So, and adding on the kind of qualifiers or that capability. That kind of thing could be constructed and you wouldn't be starting from scratch because you can take advantage of the existing data feeds and simply use a different entrance portal. But that's what CCAN really needs to define, is what do you want for your specs for that. Skyly.
And does that need to be resourced?
Very much so. Amazingly, Emilio doesn't work for free.
And, well, and everyone
I
else,
don't
I guess.
either. I don't do any of that kind of important stuff.
I mean, I'm sure this is obvious, but it seems to me that if we're going to put biology on these sensors, then they need to be standardized across sensors. Like, we need to be able to say, this sensor looks like that, you know, that if we wanted to compare sensor A to sensor B, that we could actually make the direct comparisons if we're interested in the biology that's on top of them.
I just kind of want to get back to what, I mean, we talked about this a lot. You know, do we go through tiers or do we just flag data sets and let people make their own decisions? I mean, Burke must have got some flack on this one when you brought it up, or what? People basically get insulted. You don't like our data set. What do you do with that?
So there's all sorts of places where people have insulted data sets.
So there are a number of places where, that comes up. The first is what type of measurements need to be made to qualify something as ocean acidification research, right? And that's what I was referring to this morning, is that when we said that, we tried to push a model where the fundamental physical and chemical characteristics related to ocean acidification were the tier one, the baseline, the fundamental measurements that had to be made before anything else could be added. There are a number of people who felt like that wasn't biological enough and that the biologists were being discriminated against. But then, as we said, after that, it sort of fell apart as to, if you could make a suggestion for one biological measurement that would have to be made, absolutely no consensus, right? So that's the measurement requirement. I'm personally fairly strongly in support of tiering what the measurement requirements are. When it gets to data sharing, I'm much less restrictive about that. I think any data that's out there, as long as it's got at least one OA relevant parameter, ought to be something that this community knows about. And then we can make our decisions ourselves as to whether or not we can use it for whatever thing we want to try to use it for. But I think we shouldn't say that something is a node in an ocean acidification network if it doesn't have a very clear physical and chemical basis that supports OA research, whatever that is beyond that point.
Perhaps my point on this would be to say that the uncertainty of your measurement is as valuable a piece of information as the measurement itself. And so that anything we do that reports data in a coherent fashion should think how it reports that other number as well. So the difficulty then becomes, of course, you get a measurement point because the instrument and the calibrations gave you that number. You get your estimate of uncertainty by a much more subjective approach. It's my data, it must be great, is one. The precision was such and such, which is not at all the same thing. I have no reason to believe that the precision of 3 pH measurements differ meaningfully one from another in terms of their individual within laboratory repeatability. However, what you'd really like to know is if I gave you the same sample, how closely would you get to the same number? And that's really one of the pieces that you'd like there. The other would, of course, would be how closely would you get to the right number? That's essentially what you need. So I think we need a focused strategy that says this is how you develop an uncertainty estimate that goes with the data stream. But we need to recognize that data without that uncertainty estimate is far less valuable than data with it.
So I was looking at the map. And initially up under the filter section under, we've got type. And going back to Burke's comment about, that we discussed this a couple of years ago about tiering of the data. And if we had one of our basic filters was the data tier that it came from, it would only pull out data. So whether you were trying to get a quick look at more of an estimate of what was happening, or you intended to use that data for research, you would filter it accordingly. And perhaps this same type of tool that we have up here would help us do that filtering as long as it was noted ahead of time or during entry when the data source was set up as for the type of data that it was and the type of measurements that were being made and who was making them, the type of instrumentation.
Yeah, if there's agreement in the community about what those attributes mean and what they'll be used, and they are in fact used consistently, then it is easy. I'm reluctant to use that word, but to have exactly what you're saying. I think the larger challenge is to have that agreement and to have every group follow up on that agreement.
So we can't be the first people that have asked this question about quality data that's distributed publicly. How does the IOOS program, what's the real approach, even temperature, let alone oxygen? I mean, what's the format for tackling this? I really don't think we, even though there's some brilliant minds here, but I don't think we can tackle this problem de novo. I mean, we got to draw upon people who have tackled this nut, crack this nut and move ahead.
So Francis, let me restate that question because Amelia didn't quite hear it. So you're saying that we shouldn't be the first people who have tackled this issue of how to do quality assurance for real-time data. How is IOOS dealing with that? Is that your question? Do you want to talk more about the Quartod process?
Quartod is a project that has been around for several years, but initially it was more of a bottom-up community process that did define, as we mentioned earlier, temperature and salinity and waves, I think, or something related to waves, as their initial target for stating how to document QA/QC in a consistent way. It was poorly funded, and because it was a bottom-up process, momentum was hard to maintain from what I understand, and what they developed was not implementable. That's what I've been told, that it didn't lend itself to implement it in data formats or data streams. So the documents may read great, and you may not disagree with anything that the document said, but it didn't lend itself to actually being implemented in a system. As a result, it wasn't taken up. As far as I understand, even then, Quartod was sort of the state of the art. We've struggled as a larger community with that, and IOOS has finally recognized that and has adopted it officially and funded it officially, starting 6 months ago or so. So we're hopeful that this time the process is, we just had a meeting about a few weeks ago, and the process is being consciously led to lead to results that are implementable. Did that make any sense? Or?
Well, but it seems like we are a poorly funded bottom-up effort. So, I guess what I'm looking for is, as this process moves forward, even for temperature and salinity, what are the lessons that they learn that they said, hey, if you're going to do this, this is the 5 things you have to do, or you might as well not even distribute the data. Just what are the lessons that they're learning, and I'm hoping that we can actually.
There are documents, and I can point you to them. I'm not in a position to tell you what those lessons are on the spot. But definitely, like I said, a criticism has been that the documentation and the outcome of that process over the last 8 years or so just was not conceived in a way that was results-oriented, that could be implemented in specific data formats or data streams in a consistent ways.
Well, just to provide a little bit of background, the Repeat Hydrography CLIVAR program has written documents that lays out the strategies for doing data quality control and highlighting data sets with selected flags based on the information provided by the scientists. And so that each data set has a rigid quality control that's been established by the program itself, and all the scientists participate in that process. So there are examples for each of the parameters that we would be talking about here, at least in physics and chemistry, exist for that. I don't think they necessarily exist for biology as far as I know. And as I said before, the value of that is that you can then select with certain confidence the data sets that you use for whatever analysis you want to do.
Mm-hmm.
Dick, I have a question for you. Is that you said repeat hydrography, is that also for real-time data from moorings?
I'm more familiar with the IOOS data sets, but I suspect if you go to ocean sites, they probably have similar types of materials. I just not a part of that.
I see Dan
community.
Rudnick behind you shaking his head no. And I think that's a lot of the rub is that this is not, This isn't something that can be done on the cheap. I don't think that funding has been adequate for the QA of real-time data streams. I think that, in CCAN, we said we would make these best practices and what needs to be in metadata and all of that, and everybody tried to do it in their spare time, and you can't do it that way. I think this is a fundamental issue that needs a lot of attention. Dan, do you want to comment?
Yeah, I agree. There are a few examples where it's been done well. I think Argo is another example with temperature and salinity where they've done a reasonable job of this problem. They have the advantage that it's a very homogeneous network, but they really have done a lot of work on it. Even those two simple variables, it's a lot of work to get them right and to have everybody do it in a comparable way.
Yes.
So, my bar for no is always pretty low, but I was just curious, I guess from Dick in particular. So, I mean, this democracy and everything from the bottom up is good, but if Dr. J and people want to have a climate service, at some level, shouldn't they be saying, these are the number of measurements we want, these are the standards we want? Has there ever been a sense from the top down that they have a vision of what they want?
You know that's not true. I don't want to go public with that. It's always been bottom up.
I would say that the IOOS program at the national level did establish standardized variables that everybody should be working to meet. So there has been that top-down as well as the bottom-up. I think what you're seeing in a lot of this stuff is that programs are struggling to work with insufficient budgets. And so one approach is to do very few measurements, very precisely, very well in few locations, and we learn a lot from that. Another approach has been to integrate these things out here, but we stand to fail because, does it mean anything? I always remember The Sound of Music where the Von Trapp children are learning how to sing, and Maria teaches them, and they're doing that do, re, mi, and they do, mi, mi, so, and all that sort of thing. And then one of the little kids turns to the other and says, but does it mean anything? No, you have to put words in, right, to sing a song. And so you can look at that pH thing that Emilio showed and say, but are those on the same scales and all of that sort of thing. So it depends on which activity you try to tackle first, where you put your most energy. Getting to a system that's going to be adequate for us to do the kinds of things that Andrew was talking about earlier, we need to define that, and we need to realize and be realistic on whether we can get the funding to do that. But these are some of the materials that exist.
And again, I would just like to point out to people that there's a mixture here between high quality as meaning it's adequate for what you want. That, to my mind, would be high quality data. And climate quality, which is, this is the best data we can do. And when we talk about having quality control and quality statements, I think that filtering data on it's plus or minus 1, it's plus or minus 10, it's plus or minus 100 might be relevant if those numbers were well defined. So the key feature has to be not that it's great uncertainty on the data, but that you actually do know, for good reasons that we all agree on, what the uncertainty is. And I think that it's that discussion that the community has to have. We've tried to have it in the repeat hydrography, as Dick spoke about, but even there, mostly it's, yes, this really looks consistent with the last time we kind of made these measurements. Not, yes, this is right, plus or minus X. There's an inference that you can carry beyond to plus or minus X, but most of the effort has been to say, does this actually look consistent? For the kind of data we saw today, where you can show multiple places along the same coast, should they look the same? Should they look different? Do you know? No. So every one of those has the obligation to say, this number is correct within this uncertainty. and take that on to drawing things. The other comment I heard earlier was the implication that a quick look and research were necessarily different opportunities. Sadly, no. Much research is indeed a quick look. So I think the real distinction is not that there's research data and there's the other data. It's that there's data you know how bad it is or how good it is, and data which is quality unknown except for exaggerated claim of supplier.
Jan and Emilio, I mean, I'm surprised and scared and startled to hear that it probably took a years-long deep dive into standardizing temperature data, so that we're probably over our heads in this group to think about how we're going to standardize taking data around the carbon cycle. But if we're going to do some of the very first layers that is CCAN's emerging dream, is within an order of magnitude, how much would that cost to present standardized data? What do we need to most parsimoniously begin to build out this in a portal?
I don't have a clear idea of what that would look like. I mean, not just sorry. I don't have a clear idea what that integrated data set would look like. So it's hard to, for me to envision it. But I do think the hard part is to get to that agreement of how do you add these qualifiers? What do they look like? Once that is in place, where you have clear documented agreement and it is implemented from a data handling perspective, it is fairly easy, I think, if it is consistent, truly consistent, because it is just any attribute like variable name or geography, et cetera. To take something like this specifically and expand it, for example, to the West Coast, to a new data set, I can't put a number on it right now, but if that particular component, if we build, for example, on top of what we already have with, I don't have it here, with the preliminary inventory that we put together for CCAN, that has a set of attributes. Has nothing about QA/QC, but it does have a set of attributes, and we did take pains to make those consistent, such as whether it's Group 1 or Group 2, which regional association provided the information, and a few others. QA/QC can be made with a lot of effort to be just as consistent. Once that's the case, we can bring these tools to bear. I know that doesn't answer your question, but
I'll chime in here. And I think there's 3 steps, and you're buying people's time. You're buying people. So step number 1 is there has to be agreement on what are the critical metadata, variables, parameters, whatever, the information that needs to be recorded. We have to agree on that, and we can't miss important stuff, okay? So that's process number 1. I don't know how much that costs. You're going to have to assemble people in a room, shop some stuff outside. I don't think that's a huge cost item. The second is that you need to have the time for the data managers to have that one-on-one correspondence with their data providers, so that Emilio is working with Benoit to get what his metadata information is, as well as with Dick, as well as with whoever is out there. Seattle Aquarium, we like to pick on them. So once again, that's people time, and that's a much more intensive exercise, because let's face it, you can do a lot of stuff through the web and easy load forms and things like that, but it really comes down to any success that IOOS has had has really largely, in the DMAC arena, has largely rested on Emilio's commitment to work with people one-on-one, figure out, okay, yeah, that's a little different, and I can twist it this way to get their data coming in, and it really does take that personal touch. Then number 3 is that ability to filter, like what Burke was first saying, so I'm only going to have tier 1 or tier 2 or whatever, and your metadata helps to define what is tier 1, tier 2, tier 3. That one, I can actually give you some estimate of cost, because we wrote that proposal to MARHAB between the 3 regional associations, and that was about $500K, I think. I can't remember, but I can actually put dollars to that. So that one is the most straightforward, because it requires fewer people doing that kind of data presentation, and as Emilio said, I mean, he never says easy. It's straightforward. So if he's saying easy, that's very encouraging to me. But it's those two first steps that I think are the most troublesome and time intensive, but they're approachable. That's doable.
Thanks very much. That's helpful. And the follow-up question is that with those assets, do we get anywhere close to what it is we're talking about in needing to describe the landscape of OA and the variability and where those networks are? So even if we were able to secure that, that funding, what's that get us with respect to the questions that are being asked?
Yeah, well, I think it gets us partway there, not all of the way there. I think what we see when we look at those the inventory is that, that we do have, I mean, you need the domains, right? You need to understand what's going on in the coastal ocean. And we have some of these offshore buoys, we have some glider lines, we have, down here you have Cal Coffee. We're getting a decent handle on that. Can we improve on that? Heck yes. And the wave gliders that NOAA PMEL is testing, so that gets us there. The estuaries are going to be very different. The nearshore areas are going to be very different. And that's kind of hit or miss. There are some places where you have great instrumentation, and there are other places where it's really lacking. The hatcheries, the shellfish growers have made good inroads on that. So it's those estuarine and nearshore areas that I think we need a better comprehensive strategy on. So we're, in my perspective, and please talk to others, but glass half full, glass half empty, I see that, I think we're to the point that we can learn an awful lot from this system. I don't think we have all the assets that we need, and I think we need to be very strategic, but integrating what we have, I bet we stand to learn a lot.
This is just to sort of summarize where I think Andrew's been trying to get us, but I want to know if I'm wrong. It seems like he's saying keep the complicated measurements simple. So he, as with CO2 in Mauna Loa, would rather have one really decent measurement from the Scripps Pier than 100 crappy measurements. So, I mean, if we could have Scripps Pier central from the Central Coast and something from the North Coast that we could look at 50 years from now, then we would be 3 times better than just Mauna Loa of describing long-term change on the West Coast, rather than buckets and buckets of measurements that aren't intercomparable. Likewise, if you have a hatchery, I would argue evolutionarily the oysters in Tomales Bay and maybe Whiskey Creek are already adapted to different pHs. And so there you want sort of the deviation from the long-term mean. And you're more concerned with what's my average state at Tomales Bay, and did I have an upwelling event, and did it kick down 1 pH reading? Is that essentially what you're saying, Andrew?
I don't think I was drawing the distinction. Certainly, I think it would be risky to suggest that an individual site on the California coast will quickly give you a climate picture. The 50-year may be an adequate horizon, but that would be speculative, sadly to say. The other part, which is saying that for many biological measurements that you really are probably interested in local information about the fluctuations around some local climate, is probably very true. But I say that because it's plausible to me as a chemist, not because I know it is true as a biologist. I think the key here is that we want to there's 3 layers. Number 1, making measurements. Number 2 is having adequate quality control, quality assurance of making the measurements, that they are indeed reliable to a known degree. Second, conveying that information to others, both the measurement themselves and their reliability, their uncertainty, for people to use as they see fit for a variety of purposes, but one of which is to characterize the CO2 conditions along the coast so that we can interpret what we learn about biology in those locations.
I would really like to add to what Andrew said, but I see Diane waving her hand. Is there a problem?
No, not a problem. I just have a note here from Terry, who's been monitoring online all day. And
Okay,
she's,
could I just add on to, because
Sure.
I had, and the gentleman in the black shirt, I'm forgetting your name.
Russ.
Russ, yes, thank you. I think that we need more than one strategy, and I can't believe I'm at Scripps, and I'm going to quote Freeman Dyson, but thankfully you've given me the opportunity to do that. I actually saw him give a lecture up at the University of Washington a long time ago, and he was talking about in astrophysics, you know, so many resources went into the Hubble telescope. And the Hubble was great for learning some things, but he said his daughter was in the Peace Corps, and she was in a country where there are like chickens everywhere running around, and they were just chickens always underfoot. And he said, you know, what he thought that we needed in terms of, you know, so much resources just going into Hubble was space chickens, which would be lower cost, lower quality telescopes in space, but a whole bunch of them. And so I guess my point is that I think we learn different things from different strategies. I think both have a lot of payoff. But even if you don't like that concept, what I will say is that those other sensors are out there. The Seattle Aquarium, the groups, you know, I get calls from, like, say, the Suquamish tribe, you know, we want to do something, we want to measure. So we best try to optimize that information as best we can instead of just simply ignoring it and saying, well, it's not going to be of this quality. I think that we really do learn something from that more aerial environmental description. So thank you for letting me quote Freeman Dyson. So now let's hear from Terry King.
she won. Thanks. This is, let me go back to where she was here. This is just a statement that she sent to me a little while ago. So, and we've been discussing this dancing around the maypole here, but she says, it seems to me what we're focusing on in this discussion is more about integrating current monitoring efforts. I'd like to remind the group that OA is an expanding field with a lot of researchers starting to discover it and applying for funding. Let's not forget the CCAN monitoring network can help new data gatherers by providing the guidelines, BMPs, best management practices, so that the newly funded data can be best possible for explaining and correlating within the entire California current. And then she also mentioned, and this was, Terry was responsible for taking the subcommittee, you know, the teleconferences and discussions that we had after the carbon chemistry workshop and putting them into a structure for Andrew. And the funny part, she said, the second subcommittee on QA/QC didn't make any recommendations other than do measurements should only be considered if they are, or DO, sorry.
Dissolved
measurements.
oxygen.
And that's do, D-E-W. Or D, whatever. Anyway,
Dissolved oxygen measurements.
should only be considered if they're Winkler titrated. And so, Andrew, take it away.
Okay, so you can hear we're kind of going round a little bit back and forward here. I'd like to take a comment that was made earlier by Jan about the glass being half full. In a few minutes, you will have that opportunity upstairs. I'd like to thank you all for contributing so much to this discussions today. Tomorrow, one of the key features for discussion, of course, has to be, okay, what's the first thing we should now do to move this forward so that something gets done as well as talked about? And perhaps we should restrict these things to for less than $250,000 so as to have it in your mind that we're going to do something manageable. So on that note, thinking about how you'll spend your first $250,000 and recollecting that you'll want a glass that's partly full, upstairs at 5 minutes' time, we'll have our reception. Remember, we will be clearing this room, so take all your stuff out so that it can be cleaned properly this evening. We're going to close it up once, as people leave. The cleaners come at 6. And look forward to seeing you upstairs for the reception and the dinner, and seeing you again tomorrow.
And before we leave, the day has come. One of the things that Bruce remarked, one of the things that Bruce remarked quite a while ago was how far we've really come. I mean, we're struggling a bit because this is not an easy question or series of questions to answer, but thinking about how many buoys do we have today that are measuring good quality data from where we were 2-3 years ago. And part of one of the major things that we have is to thank Andrew for his leadership because, and I would like to echo what Dick said, without you, Andrew, we would not be here. So on that little note, I would like to give you this little token of our esteem and thank you.
Thank you
very much.
Thank you very much. I'm touched and amazed that anybody should say that. As those that know this process, it's so easy to say what should have been done rather than what has been done. Thank you very much. We're partway through this meeting and partway through trying to get to where we actually have something done. I look forward to your help with all of that. Thank you.